Aromatic amines are prepared by reduction of the corresponding aromatic nitro compound. Now, what are alkyl halides? We already know from an alkane, one hydrogen atom is going to be replaced by an halogen atom. Hydrogenation means addition of hydrogen. Catalytic hydrogenation means in presence of some catalyst. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with session 2 of the chapter Amines. So in the last session we discussed about the introduction of amines and we started off with the structure of amines, classification of amines and we completed the nomenclature of amines. Alright, so in today's session we are going to start with the preparation of amines. So there are various methods by which you can prepare amine. We will be discussing reduction of nitro compounds, ammonolysis of alkyl halide, reduction of nitriles, reduction of amides, Gabriel synthesis and Hofmann bromamide synthesis. All of this we will be discussing in today's session, that is preparation of amines. So let us begin with the first one, that is reduction of nitro compounds. So aromatic amines are prepared by reduction of the corresponding aromatic nitro compound. Okay, aromatic amines can be prepared from their corresponding aromatic nitro compound. So let's discuss that. Nitro compounds can be reduced into amino group by treatment with a reducing agent such as palladium on carbon with hydrogen gas. That is, you can see here PDC, that is palladium and carbon on hydrogen gas, zinc metal with acid, another option, or else tin with acid. Okay, acid can be HCl. So using this reagent, we can reduce nitro group to amino group. So what is happening here is NO2 will be reduced to NH2. That is what is going to happen. So if you have to produce amine, which is aromatic amine, which is aniline. So if aniline has to be prepared, the corresponding aromatic nitro compound should be taken. So nitrobenzene is taken and in the presence of palladium, in presence of carbon and hydrogen gas, what you are going to get, nitro group is going to reduce to amino group. So you will get aniline, which is an aromatic amine, and water will be removed. So here also you can see another option is, instead of taken palladium on carbon and hydrogen, you can use tin in presence of an acid or iron in presence of an acid. So in both these cases, nitro group will be reduced to amino group. Okay, that is, you will get the aromatic amine. So this is a method of preparation of aromatic amine. So let's see next one, that is ammonolysis of alkyl halide. So first we are going to start off with alkyl halides. Now what are alkyl halides? We already know from an alkane, one hydrogen atom is going to be replaced by an halogen atom. So if CH4 is an alkane, CH3Cl is an alkyl halide. So you have CH3Cl. This is your alkyl group and this is the halogen. That is alkyl halide. Clear? So when an alkyl halide or benzyl halide is allowed to react with an ethanolic solution of ammonia. So alkyl halide is going to react with what? It is going to react with ammonia. It undergoes nucleophilic substitution reaction in which halogen atom is going to be replaced by amino group. That is it. Okay. So you have your alkyl halide. This is going to react with ammonia. What is going to happen? This halogen atom is going to be replaced by NH2. That is what is going to happen here. Okay, clear. So let's understand that. A chemical reaction in which cleavage of carbon-halogen bond of an alkyl or benzyl group or its aryl halide by reacting it with the molecule of ammonia or amine is called as ammonolysis. So what is exactly ammonolysis? That word means that your alkyl halide, let's take CH3Cl itself. So alkyl halide is taken. When it is going to react with ammonia, what is going to happen is this carbon-halogen bond is going to break. So you can see here also, this bond is going to break because of the presence of ammonia or because it is going to react with ammonia. That is why it is called as ammonolysis, because it is reacting with ammonia. Okay. The haloalkane or benzyl halide is heated with a concentrated solution of ammonia in ethanol in a sealed tube at 3 73 Kelvin. The reaction of ammonia with an alkyl or aryl halide leads to the formation of substituted ammonium salt. The excess ammonia removes a hydrogen atom from ammonium ion, leaves a primary amine. So let's see the reactions here. The primary amine thus obtained behaves as a nucleophile and can further react with alkyl halide to form secondary and tertiary amines and finally quaternary ammonium salt. So this first, we can obtain a primary amine. Later, from that, again, if the reaction continues, we can obtain secondary amine, tertiary amine, and the quaternary ammonium salt as well. So, you can see here, when the alkyl halide is going to react with ammonia, primary amine is obtained first. Now, this primary amine, if it is further again reacting with one more molecule of alkyl halide, what is going to happen? This alkyl group is going to be added here by replacing one more hydrogen atom. So, you will get R2NH. Again, one more alkyl halide added. What is going to happen? You will going to get R3N. Again, you can continue. One more alkyl halide can be added. You will get R4N plus X minus. That is your quaternary ammonium salt. So this method is used to prepare all those, that is primary, secondary, tertiary as well as quaternary ammonium salt. All can be obtained by just the addition of alkyl halide. Clear? So all these can be produced, that is primary, secondary, tertiary and quaternary salts from the same reaction, that is ammonolysis. The free amine can also be obtained from the ammonium salt by treated with a strong base. So instead of adding ammonia, sodium hydroxide, which is a strong base, can be also added to the salt so that you will get the primary amine. Clear? Now, let's take an example of C2H5Cl, that is ethyl chloride or chloroethane. So it is going to react with ammonia. So alkyl halide reacting with ammonia, that is called as ammonolysis. What is going to happen is H from the ammonia and Cl from the halogen will be removed as HCl. So that you can see. So you will get C2H5NH2. So instead of the halogen, what is present here? Amino group is present here. Now to this further, you can again add one more molecule of alkyl halide. So what is going to be happening? One more hydrogen atom is going to be replaced by C2H5 ethyl group. So you will get a tertiary amine. Now again, if I am adding C2H5Cl, one more alkyl halide group, this hydrogen atom will be also replaced by another C2H5. So that is how you can obtain primary, secondary and tertiary amines. Clear? So now you have C6H5CH2Cl. This is benzyl chloride. Okay. This is called as benzyl chloride, to which it reacts with ammonia. What is going to happen? HCl is going to be removed. So instead of the halogen atom, NH2 is going to be replaced here, amino group. Now again, I am adding CH3Cl, which is methyl chloride. So methyl chloride I am going to add means one hydrogen atom is going to be replaced by a methyl group. Okay. So this is how the ammonolysis process takes place. Moving on to the next one, that is reduction of nitriles. Okay, nitriles can be reduced by lithium aluminum hydride, LiAlH4, or by the catalytic hydrogenation to primary amine. So two methods can be happening here. One reagent we can use is lithium aluminum hydride, which is a very strong reducing agent, or else catalytic hydrogenation. Hydrogenation means addition of hydrogen. Catalytic hydrogenation means in presence of some catalyst. So you can see RC triple bond N. This is called as nitrile. Okay, RS an alkyl group, C triple bond N is the functional group here. So this is called as nitrile. Either it can react with hydrogen in presence of nickel. Okay, so that means hydrogenation, addition of hydrogen in presence of a catalyst. So this is called as catalytic hydrogenation, or else you can use lithium aluminum hydride as well. So what is going to happen here is you have the nitrile, that is RC triple bond N. Hydrogenation is going to happen. That means we are going to add hydrogen. First, let us add H2, that is 2 atoms of hydrogen. So one will be added here, one will be added here. So if hydrogen is added, what is going to happen to the triple bond? Triple bond will break and form a double bond. So what you are going to get here? RCH. Now the CH will be there. Double bond NH you are going to get. Okay. Now again we are going to do hydrogenation. That means 2 more atoms of hydrogen will be added on both sides. So again, what will happen to the double bond? Double bond will become a single bond, right? Double bond will break. So what you will get? RCH2NH2, right? This will become a single bond. So this is how you are getting an amine. I hope it is clear. So you can see nitrile in presence of hydrogen and nickel. What you are going to get? RCH2NH2. 2 hydrogen atoms added here, 2 hydrogen atoms added here. What will happen to the triple bond? Triple bond will become single bond, right? First place, it will become a double bond, then it will become a triple bond. So you can see CH3, it is methane nitrile because methyl group is present here. C triple bond N. So what is going to happen again? Hydrogenation is going to happen here. So we are adding 2 hydrogen here, 2 hydrogen here. So you'll get CH3, CH2, NH2, and this triple bond will become a single bond. Ethanamine is obtained. Now you have CH3, CH2, C triple bond N. Okay, so this is ethane nitrile. Again, what is going to happen? CH2 added here, NH2 added here. This triple bond will become a single bond. Clear? So this is simple reaction, that is reduction of nitriles. Now reduction of nitrile by using sodium in alcohol is called as Mendes reaction. So this is a named reaction, so it is important. So you can see it is in presence of sodium in presence of alcohol. The same reaction is going to happen here. That is, we are going to add 2 hydrogen here, 2 hydrogen here, and you will get RCH2, NH2. But the reagent is different here. Here we have used hydrogen in presence of nickel. That is hydrogenation in presence of nickel. Here what is happening? Sodium in presence of alcohol is what you are using. So that is called as Mendes reaction. So you have CH3, C triple bond, and the product you are going to get is again the ethanamine itself, but you are using sodium in presence of alcohol, which is called as Mendes reaction. Now moving on to the next one, that is reduction of amides. What is amides? RCONH2. This is called as amide, right? Okay. So amides yield primary amines on reduction by lithium aluminum hydride. Again, it is reduction of amides means we have to use a reducing agent. Lithium aluminum hydride is a very good reducing agent. So what is happening here is, you can see the CO group here, carbonyl group, that is going to convert into H2, CH2. That's it. So that way you can remember. So that means we are actually adding what? Reduction means addition of hydrogen. So instead of this oxygen, we are going to add hydrogen here. Oxygen will be removed. So CO will be converted to CH2. You can remember like that. So you will get RCH2, NH2, which is primary amine. So here also acetamide is taken, CH3, CO, NH2. What is going to happen? So reduction of amide is going to happen here. CO is converted into CH2. So you'll get CH3, CH2, NH2. That's it. Clear? Now next is Gabriel phthalimide synthesis. Okay, so this is a very important reaction. Gabriel synthesis is an organic chemical reaction in which primary alkyl halides, okay, primary alkyl halides are transformed into primary amines using potassium phthalimide. So it is by using potassium phthalimide, so it is also called as Gabriel phthalimide synthesis. Okay, so P here is silent, we call it as phthalimide. Clear? Now the potassium phthalimide on treatment with alkyl halide gives N-alkyl phthalimide, which on hydrolysis with strong alkali like sodium hydroxide or 20% HCl gives pure primary amine. So from a primary alkyl halide, we are going to produce a primary amine. So this method is used for the preparation of a primary amine from a primary alkyl halide by using potassium phthalimide. That is why it is called as Gabriel phthalimide synthesis also. So this is the phthalimide you can see. Okay. So first what is going to happen is, in presence of potassium hydroxide, water is going to be removed. So what is happening here is, you have OH here, right, and you have the H here. So that will be removed as water. Now what is left behind? Only potassium is left behind. So you will have the nitrogen here and the K will form a bond with the nitrogen. That is what is shown here, N minus K plus. Clear? Now the alkyl halide is going to be added here, alkyl halide. So what is going to be happen here is, potassium halide is going to be removed. The K and X is going to be removed. So there will be a bond between the nitrogen and the alkyl group. NR will be formed. Now again it is going to react with the strong base like sodium hydroxide. What is going to happen here? This bond is going to split and you will get a COONA and COONA, which is called as sodium phthalate, and you will get the RNH2. So from sodium hydroxide is added here, right? So you will have 2 hydrogen atoms and you have the nitrogen also. See, what is going to happen here is, this bond is going to break. Both these bonds are going to break. So from this sodium hydroxide, ONA will be added here, another ONA will be added here, and this bond is going to break. Now what is left behind? RN you are having, and from this NaOH you have 2 hydrogen also, right? 2 hydrogens are there. So that will be added here and you will get RNH2, which is your primary amine. So let's take an example here. The phthalimide is taken in presence of potassium hydroxide. Hydrogen will be replaced by the potassium first by the removal of water, right? Water will be removed. Now what is happening? Methyl chloride we are adding. Methyl chloride we are adding means, instead of potassium, what is happening? Methyl will be attached there by the removal of KCl. This K and Cl will be removed and methyl group will be attached here. Now this N-alkyl phthalimide, that is N-methyl phthalimide, is going to react with sodium hydroxide. What is going to happen? These bonds are going to break here. ONA will be added here. ONA will be added here. So you have two hydrogen atoms, you have nitrogen and CH3. So you will get CH3NH2, which is methanamine. So you will be obtaining methanamine. So I hope Gabriel phthalimide synthesis is clear for you. Now moving on to the last method, that is Hofmann's bromamide reaction. The method for the preparation of primary amines by treating an acid amide with bromine in an aqueous or ethanolic solution of sodium hydroxide is called Hofmann bromamide synthesis. So here also it is used to prepare primary amines. It is done by treating an acid amide with bromine and in aqueous solution or ethanolic solution of sodium hydroxide. The acid amide on reaction with bromine in presence of alkalis at about 343 Kelvin gives primary amine. In this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. So let us understand here. So RCONH2 amide is taken here. It is going to react with bromine in presence of sodium hydroxide. So what is going to happen here is this CO group is getting reduced, so that you can remember. So this will be removed, like that you can remember. So you will get RNH2 here. Okay, and from this you have Na2CO3. You have Na2, and from the sodium and the carbonyl group which is going to be removed, you will have Na2CO3. Then you have sodium bromide and water. Okay, so here also ethanamide is taken. So this is going to be removed and it will form Na2CO3, NaBrNH2O. So what is remaining here? CH3NH2, that is methanamine. So this is also a method used to produce primary amines. So in Hofmann bromamide reaction, the reagent we are going to use is bromine in presence of sodium hydroxide. The initial reactant that we are using is an amide. So that carbonyl group is going to be removed. Okay, and it will be removed as sodium carbonate. So in the next session, we are going to study about the physical and chemical properties of amines. So I hope the concepts that I've covered in the session is clear for you. So that's all for today. Thank you.